Okay, for page 3, we're going to be working with factoring. So if we'll remember, we're looking for the factors or the solutions. In this case, we're just looking for the factors. So if we factor, we're looking for factors of 12 that add up to 8. So if I really wanted to, this one's easy, but if I really wanted to, just to remind you, you could go 12 divided by x, and we're looking for the pairs that add up to positive 8. So 2 plus 6 would be 8. So if we were doing this by hand, we do factors of 12. 1, 12, 2, 6, 3, 4 that add up to 8. And then those would be what would go in our terms with our x. So plus 2 and plus 6. Because plus 6 and plus 2 is plus 8. Alright, so this one would be a touch different. So if we're going to do this one, we're looking for factors of 10 that when we subtract them equal 3. Or if we go into our calculator and we go negative 10 divided by x, we're looking for ones that when we add them together equal negative 3. So 2 and negative 5 would be our solution there. If we're doing it by hand, factors of 10, 1 and 10, 2 and 5. When I subtract those, I get 3. So we need the larger one to be negative and the smaller one to be positive so that we get a negative 3. Now right here also, the 2 and negative 5 equals negative 3. Alright, so this one, same thing. Remember, we have no middle term here, though, so this is difference of two squares. We could do it the same way. Factors of 64, that when we subtract them equals 0, because there's no middle term here. Or we could remember that if it's difference of two squares, we have the square root of the first one plus the square root of the second one, and then the square root of the first one minus the square root of the second one. If I was to do this way, if I didn't remember that rule, and I went negative 64 divided by x, I'm looking for ones that add up to 0. So 8 and negative 8 equals 0. So it would be 8 and negative 8. Alright, so now this isn't difference of two squares. So this one's going to be interesting. So let's take a look at this one. If we put this one in the calculator, x squared plus 9, and we graph it, it never crosses the x-axis. So it is not factorable. You cannot factor this. So you can't factor this. There's nothing that will add up, no factors 9 that will add up to 0. Alright, so let's take a look at this one. So factors of 3 up. Now we have to watch this one because this one has a term in the front. I'm actually going to save that for a moment. Hold on one second. Well, actually, let's just go ahead and do this. So what we're looking for are, we multiply these two and we get a number. So it's 6. So we're looking at factors of 6 that when I subtract them equal negative 5. So of course that's 1 and 6. So what we do with those in this case is we write down the first one, then we use these two, but we've got to add them up to equal negative 5, so this is going to be negative 6. So negative 6x plus 1x, and then we write down this. So what can I factor out of the first two? I can factor out a 2x. Okay, so once I've done that, if I take 2x out of this first one, I'm left with just an x. Then divide that by 2, I get a 3. And then I'm looking at what can I factor out of this to make this a 1x, positive 1. And then those two are going to end up being the same. And then we just group these. X minus 3. Okay, on this one, very similar. Actually, this is difference of two squares then. If you see there's a minus sign here and there's squares, they're not perfect squares, but we can do square root of 8x minus the square root of 72 and square root of 8x plus the square root of 72. And don't worry too much about that one. If there's that one that hard on the semester exam, I will just give you credit for it. We didn't do a lot of practice with those. Alright, so again, solving by factoring. Let's take a look. Whenever we ask you to solve these, we're asking where, if I draw a quadratic, what are my zeros? Where does it cross the x-axis? So I would start off, since you have the calculator, by just plugging it in and seeing if you can see this easily on the table. So x squared plus 8x plus 12. And let's see if this is going to come out evenly. We go on the graph. It does have solutions, and it looks like they are -2 and 3, 4, 5, -6. But let's look at our table just to be sure. So we're looking for where y is equal to 0. So at -2 and at -6. If we're going to do this by factoring, we factor 12. So factors of 12, that when we add them equal 8. So 12, 1 and 12, 2 and 6, 3 and 4. So we're looking for when we add them, they equal 8. So it's those two. So x plus 2 and x plus 6. So what makes this part equal 0 is -2. What part makes this part equal 0 is -6. So you can solve that either of those two ways. Alright, on 31, we got to get everything on one side of the equation so it's equal to 0 to solve it, right? So this is plus 28 on this side. So we're going to subtract 28 from both sides. And remember, those don't add together. So it's just going to be x squared minus 3x minus 28 equals 0. So again, we can go into y equals and do our x squared minus 3x minus 28 and graph and see, yes, we do have two zeros. They look like they come out evenly. Let's go into our table and make sure. So we're looking for where y equals 0. So it equals 0 at -4 and at 7. So if we were to do this by hand, like it asked us to, we would be looking for factors of 28 that when I subtract them equals -3. So 1, 28, 2 and 14, 3 and 9. And 3 and 9 isn't 1, I'm sorry. 3 times 9 is 27. So 28 is going to be 4 and 7. So when I subtract those, I get -3. So x, and which one of these needs to be negative? I need the bigger one to be negative. So that becomes negative. So -7 and plus 4. But why are those backwards? It's because we need to know what makes this 0, positive 7, and what makes that 0, negative 4. Alright, this video is getting kind of long, so we're going to move it along here. So graph the following functions. So you can do this with a calculator, it's okay, but you need to do it carefully. There's a couple things we need to do. X squared plus 1 graph. Alright, so what we want to do is we want to get this vertex point, the lowest point, where y is the lowest, or if it were turned the other way, where y is the highest. We want to make sure we get that point, and at least one point on either side. So where y is the lowest, seems to be right here at 0, 1. And if we'll actually graph a couple of these points rather than just drawing the line, we'll get a lot better. So negative 2, 5, negative 1, 2, 1, 2, 3, 4, 5. And there's going to be another one right on the other side. Remember, those are called symmetric pairs. And we get a pretty good graph. Alright, so let's look at the next one. Y squared minus 4. So we can kind of see where it is. So we're going to look for the vertex here in our table. So where y is the lowest, looks like it's at 0, negative 4. And at least a couple other points here. So how about 3, 5? 1, 2, 3, 1, 2, 3, 4, 5. And there's going to be another one right on the other side of the line of symmetry where the vertex is. 1, 2, 3, so 3 on the other side. And we can draw a pretty good parabola. Alright, so same thing on this one. 1 over 2 x squared. We're going to look for that vertex, which is right there at 0, 0. And then we're going to find, don't just draw it, go ahead and find a couple of points. So 0, 0, so how about 2, 2, 1, 1, 2, 1, 2, and there's going to be another one right on the other side. Excuse that pause. I was making sure that was right. And then how about another one? How about 4, 8, but that kind of goes off this graph. 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. There'll be another one over there. And now we can draw a parabola. So what is the range of the function y equals x squared minus 2 when the domain is this? So remember, domain is x and range is y. So all we're going to do is take this function, put it in here, and go on our table and look for when x is 0, y is negative 2. When x is 1, y is negative 1. And when x is 2, y is 2. Alright, that's the end of this page.